Our airways tissue's protective response is what causes the manifestations of asthma. When we are exposed to an antigen, our body causes an inflammatory response. When this antigen is exposed within our airway, the immune response can cause the airway to swell and result in wheezing and difficulty breathing. The inflammatory process is an immune response when the body determines that it has been invaded. The initial response is the activation via messenger dendritic cells that bring the antigen to the T helper cells, which differentiate into T helper cell type 2, releasing several interleukins, such as interleukin 4, 5, 8, 13, 17, 22, 25, and 33, and mast cell degranulation. These cells contribute to vasodilation, vessel permeability, mucosal production and edema, bronchial muscle contraction, which all result in airway obstruction due to the bronchospasms and the airway narrowing from the mucosal secretions. The early asthmatic response happens within the first 30 minutes and is usually resolved within 1 to 3 hours. The early asthmatic response centers around this previously outlined inflammatory response. The late asthmatic response happens approximately 4 to 8 hours later and involves an increase in the airway's hyperresponsiveness. During the late response, the action of the lymphocytes, eosinophils, neutrophils, basophils, and lymphocytes cause another latent release of inflammatory mediators and newly formed mediators, which further increase the airway obstruction through more edema, mucus production, and increasing bronchospasm. This late response of eosinophil mediators can cause tissue injury and airway scarring. The damage to the ciliary epithelial cells can cause impaired ciliary function, leading to that accumulation of mucus and cellular debris forming airway plugs, which in turn can lead to oxidative injury and chronic inflammation. If this is not treated, it can turn into irreversible airway damage, resulting in remodeling through subepithelial fibrosis and the smooth muscle and mucus gland hypertrophy. If the airway becomes obstructed, this leads to difficulty with inspiration and especially expiration. When airflow is not uniform throughout the lungs, it can cause uneven trapping within them. This in turn increases the pressure within the intrapleural and the alveoli, decreasing alveoli perfusion, which leads to hyperventilation with the result of early hypoxemia with no CO2 retention. The hypoxemia triggers that respiratory drive, increasing the hyperventilation, which causes the PaCO2 to decrease and pH to increase, causing alkalosis. If this continues and the air trapping increases, the lungs and thorax can become hyperexpanded, leading to the muscles to be at a mechanical disadvantage, which can lead to increasing CO2 retention and respiratory failure if not reversed.